everybody, and welcome back to our reverse shell coding. And in the previous video what we did is we coded a function that will be able to download a file from the internet to the target PC. Now let's see what else we can code for our reverse shell for it to have multiple functions that we can use once we actually infect the target with our payload. So let me just zoom this in and we will navigate to our Python programs, reverse shell, and we will nano our reverse shell. Now let me just delete from the previous compilation these unnecessary files, so we can only have our two main files, which is the server and reverse shell, and let me nano my reverse shell. So we have the download function right here. We perform the connection every 20 seconds. Now let's see, for example, how we can take a screenshot from the target PC. For example, let's say they are using Facebook and sending messages, and we want to, for example, see what messages they are sending. Without implementing a keylogger yet, we can actually run a screenshot and see their entire screen as many times as we actually want. So in order to do that, we will need to import a library, which I'm not really sure if it comes with the PyInstaller. Maybe we will need to install it while compiling the program. So the library is called MSS, and we will import it like this. So from MSS import MSS. Now before I do this, let me just check out in Python import MSS. Okay, so Python 2 doesn't have it. Let me just try to import it like this. So from MSS import MSS. Okay, so we know that the library is not in Python 2 and we can install it with pip install MSS. Now if this doesn't work, we will just install it for the actual PyInstaller in the wine folder, since that is actually where we need it, but you can also install it for your own Python in Kali Linux if you want to. We will not really be running this on the Kali Linux target, we will be running it on the Windows machine, as usual. So we can see it successfully installed, and now if we go to the Python and import MSS, it is there now. So you also have it in Kali Linux Python. So we imported it. Now let's make a function right here, for example, and we will call it screenshot. Let's leave it for now on. Right here, we will code it in just a second. What we want to do is add an actual option right here. So we want to create another else if statement for the actual screenshot. So let us add it right after the get command. We can just go down here, make else if, and then the usual command. And then let's count the letters. So screenshot actually has 10 letters. So we want to make sure that we specify everything until the 10th character equals to the screenshot. This is the function that we will use in order to screenshot target PC. So we will just type in the server command line screenshot, and then we will get back the screenshot from their PC. And what we will try, since this doesn't work every time, for example, I tried getting this to work on Windows XP and it just doesn't work. I believe it works on Windows 10 and Windows 7. On Windows 10 it works for sure, on Windows 7 I'm not so sure, we will have to try it out later. So we need to run it in a try and except rule in order for our program not to crash, for example, once we encounter a target that cannot take screenshot. So what we will try is we will try our screenshot function that we will code in just a second. Once we do the screenshot function, we need to send that screenshot to our Kali Linux machine. So basically, since we are on the reverse shell code right now, what we will do is we will actually open that file for reading bytes, and we will send the actual data to our server. So now before we do any of that, the actual screenshot, once you use the MSS library, will save the screenshot under the name like this. So monitor -1 .png. So this is the name how this MSS library will save the screenshot under, and every screenshot will be actually saved under this name. So that can present a problem to us, because if we make one screenshot and it saves under this name, and we want to, for example, take a second screenshot, and we take it, it will rewrite this screenshot right here, because it will have the same name. So we will no longer have the first screenshot. So we need to actually make sure that doesn't happen. So how we will do that is we will actually fix that in the server-side code. For now on, all we want to do is open the file under this name, since after we perform this function, there will be a screenshot on target PC. We want to open it, read data, and send data to the server. And in the server, we will rename this so it doesn't actually rewrite other screenshots that we take. So first of all, with open and close brackets, between the double quotes, let's specify monitor -1. Now make sure to specify exactly the same name, otherwise this will not work. So PNG, and then comma, and we want to read bytes from that screenshot. Since we are getting a picture, whoops, we don't need another bracket. We want to open it, let's say, as CS, so shortly for the screenshot. And what we want to do is reliable send, reliable_send, base64, base64 dot b64 encode. Since we are the one that are actually sending this, we want to encode, and the thing that we want to encode is the sc, or our screenshot dot read. So let me just count the brackets. We have 1 open, 2 open, 3 open, and 3 closed. So everything is good right here. And also, for example, let's say that the reverse shell is running on the desktop. So the target found it on the desktop, double-clicked it, opened it, and we took a screenshot. The monitor-1.png file will be saved on the desktop, which can actually trigger some users. They basically find the screenshot of their own PC, so they maybe believe something is wrong by then. So what we want to do is actually delete the screenshot as soon as we send it. Now you will notice that you will not even be able to see the screenshot for a fragment of a second, so nothing will be suspicious. If after the actual opening of the file and sending, what we want to do is use the OS library, and we want to .remove, which will remove a file that we specified between the brackets. So let us just copy the name of this file, which is monitor-1.png, paste it between these brackets, and this will remove the actual screenshot right after we send it. And in the except rule, what we want to do is reliable send _send, and let's send a string, basically a string that will say failed to take screenshot. Now why we are sending the string? Well, basically, if we fail to take the screenshot, we will have a file, or not a file, we will get prompted this string right here, failed to take screenshot, and then we will know that the screenshot function doesn't really work on that target. So now that we did this, what we need to do is actually code the actual screenshot function, which is rather short. It is just 2 lines, so don't worry, nothing really too much. Our MSS library already did the entire job for us. All we need to do is type with MSS, and then as a function, as screenshot, so this is the name, you can specify anything you want, it doesn't really matter. We want to use screenshot.shot. And this will save the screenshot for us. This is the entire screenshot function. So basically, if I'm not mistaken, this should be entire actual code for the screenshot. Now let us save this. So Ctrl-O save, Ctrl-X to exit, and let us nano our server and see what we need to do once we actually get the screenshot back. So let's first think about it, or let me just at the beginning create the actual else if statement. So else if, we need to perform the same thing, command, first 10 characters, equal to screenshot. Let's think about it, what we actually need to do right here. As I said, it will save every screenshot as the same file, so we need to change that. We will use a counter, for example, or not a counter, we will just increase the variables. For example, let me show you right here, so maybe you will understand it better. If you go down here, and for example, at the beginning, you create a variable count equals 1. So count equals 1, and that is a global variable, so we can use it in this function right here. The reason why we are using the global variable is because we need to actually increase that count variable every time we run this screenshot function in the while true loop in the shell function. So let me just show you. We will actually receive the data first of all, But before receiving it, we need to open the file under a specified name that we want. So what we will do, in order for that file not to rewrite, since every screenshot has the same name, we will name it screenshot %d, and then we need to use the %count to be replaced instead of this %d. So since count is 1 at the first screenshot, it will be the name of screenshot 1. Then we will increase it at the end and it will be screenshot 2, and so on and so on. So since we are the server, we need to open for the writing bytes, and the name, we can name it fin. Doesn't even matter. You can name it anything you want. Or maybe if it is actually confusing for you, just name it just screen, so you know it is a screenshot file. And actually we need to receive that file right now. So let's do it like this. We will create an image variable, and that image variable will store the data from the received screenshot, so reliable receive. And since we encoded it with base64 encoding, we need to decode it, so we will create image underscore decode, or decoded, equals base64.b64 decode. And the thing that we are actually decoding is the image itself. So just type here image. And now what we want to do, since the try rule in our reverse shell actually saves the image or sends the data for the image, what we want to do is, if we successfully took a screenshot, we want to save that to a file. If we didn't take successfully screenshot, that means that we are getting the string back, which will say failed to take screenshot. In that case, we want to print it to our screen. So in order to check that, we can just check first 4 characters, for example. So if image underscore decoded, and then first 4 characters equal to this string, which is the string that we specified at the beginning of the failed to take screenshot function, then we want to print image underscore decoded, because that means that the actual image failed to take. So image underscore decoded. And in any other case, we want to actually write it to a file, because that means that we successfully took the screenshot. So we'll just use screen.write. And we want to write image underscore decoded. And make sure that you increase the count variable right after you do this. But not right here, since that it will increase it even after you don't take the screenshot. You want to increase it right here. So count plus equals 1, which will just increase the count variable by 1. So that is the entire actual program. Let us now save this. We can compile our reverse shell. So wine root drive c python scripts installer -- no console -- what's the next thing? Okay, one file, and then reverse shell.py. Let us run this with enter. This will compile, and then we will run it on the actual Windows 10 PC. And later on, when we'll actually code the threaded server, which will accept multiple connections, we will try to run a screenshot on Windows 10 and on Windows XP. So let's wait for this to compile. Now, if my IP address changed, we will need to compile it once again, since I just started Kali Linux. Didn't really check the IP address. Hopefully it didn't. Okay, so let us check the IP address, .1.9, and let me check the IP address that is specified in the actual Kali Linux machine. No, pardon me, in the program. Okay, so it is .1.9. Good. So right now, let us plug in my USB drive. Or let me actually show you another way that you can download this reverseshell.exe without plugging in your USB drive. You can just go to the Google Chrome. If you, for example, for some reason don't have USB drive, then you can just go cd dist, and you can move this to the move the reverse shell to the var/www/html, which is the standard Apache 2 folder. So you just move it right there. You can see it's no longer here. We can delete the rest of the files. And all you need to do right now is actually run the Apache 2. So you can do that with service Apache 2 start. And this will start the Apache 2 for you. All you need to do right now in order to access that file is you need to know the IP address of your Kali Linux machine, which we already really know. It is 192.168.1.9. So we can just go right here, just type 192, oops, 192.168.1 dot, oops, we have two dots, so .168.1.9. Okay, so we still have the Facebook login page from the previous tutorials. Let us just remove the actual Facebook login page so we can see the file. If we remove index.html, we only have our reverse shell.exe. If we refresh, here is our reverse shell.exe. So all you need to do is just click this in order for this to download. You can see it downloaded successfully, but you will notice one thing. Let me just show you. Once it is on our desktop and we downloaded it from the actual Apache 2, it will no longer run as the USB transportation. As you can see, this is something that we didn't really encounter before. Right now it says Windows protected your PC, prevented an anachronized app from start running. This app might put your PC at risk. All you need to do is go to the more info and run anyway. So now our reverse shell is ran, and for some reason we get fatal error. Okay, I think I know what the reason is. The reason is because we actually only installed the MSS library for the actual Python in Kali Linux. We forgot to install it for the Python in Wine, which for some reason I said we need to do that and then I forgot to do it. But let me just do that real quick. In order to install it for the Wine, run this command right here. So wine/root/.wine/drive/c/ Python 27, I believe, and then python.exe. Then you need to specify -m and then pip install and then MSS. Run this command, and this command will basically just download the MSS library for the Vine, and then hopefully everything will work as usual. So until then, I will just plug in my USB drive, because I find it easier to actually transport via the USB. Okay, so we can see here it is. Now we have the MSS library. Now we can actually, let me just find where the reverse shell is. Okay, so here it is. Let us navigate to the previous command. Here it is. I will compile this real fast so we don't waste time. Everything is finished. Go to the dist, move the reverse shell to your Windows 10. So root media, or it is media root. Or basically I just need to plug in the actual USB drive before I try any of that. So /media root Kali Live. We move the reverse shell. Hopefully that was the error. I really can't think of anything else being the error. So remove this, remove build, remove reverse.spec. Let us unplug my USB drive. And I can run my server for the listener, even though we can actually run the reverse shell first, as we saw that we actually created a function to connect every 20 seconds. And right now, if we run, first of all, you will notice we don't get that error prompted, we don't get that warning prompted that says this app might put your PC as a target or something like that. I'm not really sure what it even said, but it doesn't even matter. Right now it doesn't say it because we didn't download it from the internet. And here we get the connection back. So all we need to do is first lower this so you can actually recognize the screenshot once I take it. And if I just type screenshot, oops, local variable count referenced before assignment. Okay. What do you mean? So nanoserver.py. Yeah, actually, let me just double check everything right here. We need to actually code this at the beginning because it goes through all these functions and then it runs to a count variable which it doesn't really recognize. So let us code it. Just move the count equals 1 at the beginning, even though we didn't really run that function yet, but it doesn't even matter. Let us just try once again. we listen for the incoming connections. It should come any second. As you remember, we have a timeout of 20 seconds before connecting. And as soon as it does, we will just, first of all, check a simple command to see if our program works, and then we will run the screenshot and see how it looks like. So here it is. Let us just run who am I just for a simple check. Then I can lower this so you can see the screenshot better. And if I just type screenshot, what do you mean count referenced before assignment? Oh, I think I know what does it mean. Sorry about that. It doesn't really know what count variable we are using. We need to specify right here at the beginning that we are referring to the global count variable. I believe that is the problem. Sorry about that once again. And hopefully third time, third luck, so we will be able to run this right now. Even though we crashed already 3 or 2 times, something like that. But hopefully everything will be good to go right now. The problem was, I believe, because that global count string, or pardon me, global count command wasn't really implied in the actual shell function. So let us just run it straight away. Screenshot, we can see it finishes relatively fast. Now let me just lower my screen right here so you can see. Screenshot, if I run it, you can see there really isn't anything on the screen that appears, such as the monitor1.png, since this performs really fast and it sends the data, and as soon as it does it, it will remove the screenshot. And if you want to check actually where the screenshots are, we can first of all press Q to quit the program, and you can just type ls and you will see in this folder there is screenshot 1 and screenshot 2. Let us navigate to that folder. It is in the root, Python programs, and then reverse shell. Oops, we need to go to the places, I believe. Then go to the computer. Then find the root right here. Let me just find it. Here it is. Go to the Python programs. Go to the, where is it? Reverse shell. And screenshot 1 is basically just the screenshot of our full screen Kali Linux, as you can see. You know it's a screenshot of Windows 10 PC because we can see our Windows 10 icons down here. And the second one is more convincing since we can see even the Windows 10 background in the actual screenshot. So our screenshot actually works perfectly. It is even a good resolution, so everything is good to go. You can see everything in the actual picture and you can perform as much screenshots as you really like. All I need to do afterwards is just delete these screenshots if you want to. So remove screenshot 1, remove screenshot 2. And you will be good to go for running the next program. So that will be about it for this tutorial. What we will do in the next one is we will code a simple help function that will print the help to anyone using our program. So we will just implement all of these things that we coded in a help function, and later on we will continue implementing more things to our actual reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye!